The major problem with farming in the desert, with growing vegetables in the desert, or anything in the desert, is water. Today, much of desert farming is done with fresh water that's pumped from deep, deep underground, from water sources that don't get replenished. So essentially, we're pumping water out of the ground that will not be replaced. So what we need to do is learn how to use salt water to generate fresh water from salt water and to use salt water for cooling.
The solar biofarm is a concept that we are developing for creating a low-energy greenhouse that would basically have a minimal use of resources when it comes to water that is treated for irrigation, when it comes to electricity usage for auxiliaries, for systems in the greenhouse.
The real driving force behind the solar biofarm is to create and research a greenhouse that can be used in a hot and a humid environment, such as what we experience on the western coast of Saudi Arabia. The things that plants really struggle with in this environment are the temperature and the lack of water. Those are the two things that we're really working on overcoming in this solar biofarm greenhouse. The first step starts with a windmill, and the windmill extracts seawater and supplies it to the liquid desiccant cooling wall, which is built of bricks made of a local rock known as Pozzolan. And these bricks are very special and unique because they can resist the strong corrosive properties that are inherent in the liquid desiccant system. And we have two actual walls. The first wall is a liquid desiccant cooling wall that's designed to remove humidity from the incoming air. After the liquid desiccant cooling wall is another wall, which is also made of the Pozzolan bricks, that is supplied with the seawater or the brackish water. And that uses evaporative cooling, where the temperature of the incoming air is reduced via evaporation of the seawater, so that it's in a temperature range that is much more favorable for plant growth. A unique roof system is designed for the solar biofarm that actually excludes the heat-causing rays of the light and enhances the photosynthetic range of the light that enters the greenhouse. So it keeps the temperature low while at the same time benefiting the plants by providing additional photosynthetic opportunities for increasing the energy in the plants and thereby increasing plant growth and production. The question of a water supply is being addressed in two ways. The first is through the use of a system known as condensation irrigation. Condensation irrigation uses solar stills, the same windmill that's supplying brackish water to the evaporative cooling wall also supplies saline water to the solar stills, which are heated to produce humidity. That hot, humid air is sent underground via pipes where it then condenses because underground is cooler. Condensed water vapor underground then percolates and naturally flows out into the surrounding soil for use by the plant roots. And that air is being drawn underground using a solar chimney or a wind-powered ventilation fan, again using renewable energy sources. Another source of water for the greenhouse is the use of solar stills to turn brackish water supplied from the windmill, and this is evaporated and then condensed within the solar still into a pure water form, and it runs off into a tank that can be used for irrigating in the greenhouse.
المزارع الشمسية تعتمد على تكنولوجيا البادية، the Bedouin technology. البدوي عاش في الصحراء آلاف السنين، صمم خيمته وقربة مائه بحيث يكيف الهواء ويشرب الماء البارد بالطبيعة بالسليقة. لكن لو أعدنا هذه الأنظمة لوجدنا أنها تطابق الديناميكا الحرارية والديناميكا الهوائية والهيت and mass transfer بعلمه أو بدون علمه.
I have a great deal of respect for engineer Nassar Madhoun, who has devoted a lifetime to figuring out how to use sophisticated thermodynamic reasoning to implement simple systems that can be built and operated by people without a lot of education.
Bedouin technology نعني البساطة، نعني الاستدامة.